So we have a special guest speaker this evening, Peter McMahon, and he is the manager of the Kitt Peak Visitor Center, and he's actually talking to us on site from Kitt Peak. So take it away, Peter.
All right, thanks, Paul. Glad to see you guys, and hope you can see some of the observatories behind me here. A little bit of background. I originally am from Peterborough and from Toronto. Went to Ryerson, now Toronto Metropolitan University for journalism, and specialized in science journalism. Did some work producing for Discovery Channel and different science and geography magazines and astronomy magazines. And ended up, in addition to working for CTV News and Discovery Channel and a number of other broadcasters and news outlets, eventually moved to Jasper to co-found Jasper Dark Sky Preserve and the Jasper Planetarium and observatories there. I worked there for just under 9 years as the general manager there. I'm still a co-owner there, so as you can imagine, we're anxiously awaiting news of how things are going down there. But meanwhile, last summer, my wife found a job ad for a management job with Uncle Sam down here in Arizona near Tucson, for heading up the visitor center at Kitt Peak, as Paul said. And so one thing led to another, and got a job offer, and we now live in on the outskirts of Tucson. Which people sometimes mistake for Tombstone. That's a few thousand people. Tucson's like 1 million people. And it's just to my right. Phoenix is almost directly behind me. And we are about 1 kilometer above the desert floor, 2 kilometers above sea level. And I want to take the opportunity over the next, how are we doing here, 27 minutes or so, to take you on a tour of Kitt Peak. Rather than move around and risk the Wi-Fi going down, I've pre-filmed a number of things, and I can also turn my camera around and show you some of the other observatories. So I'll just show you real quick here. You should be able to see 3 or 4 or 5 other observatory domes here. And we'll come back to that in a little bit. I've got some close-ups to show you of those. I'll tell you a little bit and talk to you a little bit about the science, but mainly about, I want to take the opportunity to actually take you into these telescopes. And if you've got questions about the science happening here or the engineering end of things, or just life up here on the mountain. I don't live here, but I do work here part of the week in downtown Tucson. I can tell you a little bit about that. We'll come back to this one, but the main telescope that you see behind me here, and I'm going to go on and off with my sunglasses here when the sun pokes out, is the 4-meter Mayall telescope. Some of you may have been to Kitt Peak before. For those of you who have, I want to give you a little bit of a update on what's new here, from the perspective of a Canuck who's now living in Tucson, living in southern Arizona. And if you've never been here, I'll be really excited to show you a number of things. But like I said, if you have been here before, I'll also be talking about some of the things that are new, kind of slightly pre-COVID and post-COVID. That 4-meter telescope behind me, the building that it's in is about 200 feet tall, just under 200 feet tall. You can easily see it with the naked eye from downtown Tucson. From our house in the suburbs in western Tucson, we can see the detail between the dome and the telescope itself. And I'll tell you a little bit more about what's being discovered there. I'm just feeling a raindrop on my hand right now, and I'm going to roll the dice and hope we're okay, but you might have heard some rolling thunder as well. It is monsoon season, and I'll just turn around over here so you can see a little bit more of the sky heading towards us. If it gets really bad, I'll close the roof on this rooftop observatory that we're in. It's a 16-inch RC Cassegrain telescope on a roll-off roof. And while I'm looking around here, I'll just show you that direction. That is California, the very farthest mountain, if you can see, and then to the left, the far left before that, that gray ash dome there is Mexico. And you might also be able to see further down on the ridge. We may not have time to talk about all of those, but there are several radio telescopes, including a 75-foot radio telescope. So that's a little bit of the lay of the land. What I'd like to do is take you on a tour. I'm just going to spin this around and look with you to make sure you can see what I'm seeing. There we go. So the telescope just next to the larger telescope there in the distance. So I'll just put it in the center of the frame right there. That is our 2.1 meter telescope. And it's where decades ago, renowned astronomer Vera C. Rubin, who now has a state-of-the-art major observatory in Chile, who bears her name, did pioneering work in identifying the nature of dark matter. And sorry, that was just someone on the walkie-talkie say we're still fine to not shelter in place. It sounds like I'm good to be outside with you here a little longer. I'll just show you a quick visual view, a quick still view inside this observatory here. So I'm going to share my screen. Hopefully we're good with that. There we go. I'll tell you also, just while I'm getting ready to do the screen share, we were actually, scientists here are moving the mirror of one of the telescopes here. And that's actually, it's been re-illuminized and it's heading back soon in the next few days. There we go. I think we can see the, let me know if not, but we can see the view inside this observatory here. And this is the 2.1 meter telescope. And there we are. There we are, a little zoomed out there. This was the first major telescope that was built at Kitt Peak in the early 1960s, 1962. The observatory was founded in 1958. And this telescope, and I'll just show you what, this is what visitors see. So this was taken next to the telescope. Visitors on site don't get to see that. There's a viewing gallery. And I was constantly amazed when I came here for the job interview process, and afterwards, once I started leading the visitor center at Kitt Peak, how much thought was put into public outreach, even from the get-go in the 1960s, in that a lot of the major telescopes here have viewing galleries that allow tours to happen without getting in the way of science being done, of calibrations and other things that are happening in the daytime. And then we have nighttime tours as well, and I can talk a little bit about that later. I'm also going to show you some of the daytime views of these telescopes. Okay, I'm going to stop sharing that. I'm going to show you one more telescope. There's going to be probably four that I'll take you inside. So that was one of the major telescopes, but not the biggest one by a long shot. The next one I want to show you is the WIYN telescope. And there's a lot of acronyms, but that stands for Wisconsin, Indiana, Yale, and NUORLab, which is an acronym in itself for the organization that runs Kitt Peak. It also stands for NASA now as well. And some of those universities have dropped off. Princeton has come on. But that telescope, I'm just going to move the view around here so you can see where that is live right now. And then I'll show you some pictures and video that I got earlier for that. So right in the distance, you'll see sort of a boxy telescope. Let me make sure I've got that right. There we go. So to the left of the telescope that seems closest, that's from the University of Florida. But in the distance, beyond that dome telescope that's right here in the parking lot of our visitor center roll-off roof telescope, you can see that telescope with a boxier, you could call it a dome over top of there. And I'm going to show you a video outside that telescope. That was not taken by me. Most of these were, but this was not taken by me. But it gives a really good sense of the mountain and this telescope as well. I'm just going to screen share that here. Okay, right on. I'll play this. We'll take a look at this view here that was filmed about half a year ago on site here. So this telescope here, the WIYN telescope, is, and we'll go inside it in a second, is basically responsible for characterizing, identifying the masses and densities of different dwarf planets previously discovered by the TESS survey. Here we go. You can also get a sense of the sheer height here. We're kind of, when you drive up to Kitt Peak, you're kind of driving up, spiraling up a pencil, and you park on the eraser, and we're on the eraser of the pencil right now. This is a 3.5 meter diameter mirror. And again, this telescope's mirror is actually being cleaned in the illuminizing chamber of the large 4 meter telescope that you'll see in the distance that's directly exactly behind it now. Um, that telescope is home to a experiment that is probing the depths of dark energy, which I'll show you a little bit more about in a few minutes. But first, let's go inside the WIYN telescope. I'll show you a little bit of the close-ups of the mechanisms that are actually discovering not only the masses and densities of existing exoplanets, already discovered exoplanets around other stars. There's some of the radio telescopes there in the distance down the ridge, but also new exoplanets as well. So this is a look at the telescope inside, and what you'll notice compared to the 4 meter telescope, which is early 1970s era technology, this is mid 1990s era technology, much easier to get it into the smaller space. They realized that that height off the ground of 180 feet almost was not needed, and this telescope, there we go, there's the mirror there, is using an experiment called NEWID, which is spelled NEID. And that's essentially using a very high fidelity one fiber optic strand, as opposed to thousands on the next experiment I'll show you, to look at star systems and find out things about exoplanets and even find exoplanets using the radial velocity method, i.e., looking at the wobble induced in a star and denoting that there is a Jupiter mass or bigger planet around that. Here's a close-up look. We'll actually look inside that NEWID experiment when they had it open for servicing a few months ago, and you can see a little bit of light in there. But this is basically off to the side of the telescope. This telescope has not adaptive optics, but it has optics where the surface of the mirror is changed on a second by second basis according to what angle it's pitched over on, to make sure it stays the shape it needs to in order to have that extremely, there we go, we'll just unshare the screen here. There we go. High fidelity way of detecting things swinging around distant stars, planets swinging around distant stars. The other really interesting thing about it is it's probably the loudest telescope on the mountain. It sounds like two semi-trucks racing each other down the highway, and that's because those are fans that cool cryostats that the fiber optic lines go down to feed information down to the brains of that telescope, the fiber optic line being the eyes of that telescope. After light from the main mirror hits that fiber optic in that experiment off to the side. Want to take you on a tour of our largest telescope now, and then we're going to end on telescope number 4. And if there's extra time, I can show you a few others, but we'll maybe do Q&A first if you've got any questions. So that's telescope number 2 of 4. Number 3 of 4 is the biggest telescope by far on the mountain. At the time that it was built, it was the second biggest telescope in the world in 1972. It's the Nicholas U. Mayall 4-meter telescope. And let me just go to some visuals of this and I'll tell you a little more about it. I mean, you can see it. I'll tell you, it's behind me right now. There it is, live in the flesh. Again, 180 feet tall, 18 stories tall. You may be able to see, let's see, let me get my mouse arrow here and I'll get my head out of the way. Right over here, there's a slight sort of white discoloration. That's a pickup truck. It's about that size to give you an idea of scale. This telescope is creating, scientists at this telescope, using a new device mounted on it, are creating the largest, most detailed 3D map ever of the universe. This is 1970s technology, but the device mounted on it, DESI, which stands for Dark Energy Spectroscopic Experiment, is an almost brand new device. It was put on just before COVID, I believe either 2017 or 2019. Definitely was in use in 2019. But it went fully into use in earnest after COVID. It actually finished its mapping survey, the first phase of its mapping survey, early, and you can Google that and see YouTube video of these galaxies plotted out. I'll tell you a little bit more about that once we actually go into the telescope. So let's go do that. I'm going to screen share again, and I've got some visuals, some still images to show you that I took earlier inside this telescope to give us a sense of what it's like to tour these places without actually having to take the time for me to drive over and have the Wi-Fi drop out. So here we go. We're going to take a look at the inside of the Mayall 4-meter telescope here on Kitt Peak. So this is, let me just full screen this here. Most of the building you saw is not this, but this is a vast sort of, this is like a tenth the size of the Air Canada Centre. It's quite large inside. It's actually larger than it needs to be. The Department of Energy, US Department of Energy, which runs this, is possibly going to be upgrading this to a 6-meter mirror. There's more than enough space in the Cassegrain cage to put bigger optics, and it's suspected that even though this telescope was slated to be divested between 2012 and 2016 and possibly bulldozed, the Department of Energy came along and said, we have this experiment that has 5,000 fiber optic cables, or 5,000 fiber optic lines that look like this right here. And I've actually got one of them here that I'll show you up close in my hand in a second. But these 5,000 robot positioners position 5,000 individual fiber optic strands in this amount of sky, so several degrees of sky, wide field. It's a prime focus telescope, but it turned out this was the only telescope available and beefy enough to take this 60,000-pound instrument that holds these robot positioners. Those positioners are basically pointed to this particular field of view, and each positioner positions a separate fiber optic line pointed at a particular galaxy to measure the spectra of that galaxy. And in doing so, it can find out things about that galaxy, how it is moving. You might hear some more thunder. I haven't seen flashes of lightning, so I think we're fine. How it is moving in respect to the galaxies near it as the universe expands, and map out where those galaxies are as they're expanding, finding out more about the expansion history of the universe and the nature of dark energy. So it's kind of cool. I'm going to undo the screen share here for a second, because I want to show you this is really neat. I'm going to stand up and hopefully not lose the laptop off its cable here. But across the valley, where we've seen this 2-meter telescope right over here, this was where Vera C. Rubin was pioneering, just in the middle of the view right now, was pioneering the exploring the nature of dark matter. And then across the valley, those that work paved the way for the exploration and discovery of the nature of dark energy in the telescope behind me. I just think that's kind of cool. I'll show you before I go back to screen sharing. This is one of these robotic positioners. This is a broken one. That's why I'm allowed to have it. There are 5,000 of these. The whole experiment is, in Canadian dollars, is just under $100 million. That's just the experiment, that black part at the prime focus of the telescope, not the observatory of the telescope itself. But this positioner would sit in a pedal, sort of pie shape, with about 1,000 or so of these. This is missing the fiber optic line. The fiber optic line would be going along here. And you can actually see, if I hold it up correctly here, you may actually be able to see right through it if I hold it just perfectly here. And this is, okay, you can't quite see it, but through there, this whole thing is hollow. That's where the fiber optic line goes. It sits here. The fiber optic cable goes up here. And this little motor here, which is, I'll hold my finger up so you can see the size of it. A little motor with a little gear, that's it, there it is against my fingernail, is what positions one of the two axes for this this fiber optic cable to move back and forth. The other axis is by this spinning back and forth. So this sits stationary in the pedal of 1,000 of these. There's 5 of them. And this moves back and forth and positions this fiber optic cable. So why does it position the fiber optic cable? It's to point it at a particular galaxy. This sort of thing, this sort of survey isn't new. I'll just go back to some of the visuals here while we're talking about this. This sort of survey isn't new. It's been done with the Sloan Digital Sky Survey and other such things. But those, excuse me, were using plates where there were basically holes cut out for where those galaxies were. So you would get the light from the galaxies, but not the stars. There's a much more impressive view of the telescope during a VIP tour. The public does not get to see this. There's a viewing gallery similar to that 2.1 meter telescope. So the public doesn't get to see this, but these are people from the National Science Foundation who fund Kitt Peak. And you can see the scale this is on. You can see the mirror. There's about 3.8 meters worth of usable, or sorry, 3.6 meters worth of usable space on that mirror. That light comes off the mirror into the prime focus of the DESI experiment here. And again, the way this used to be done is plates, metal plates with holes punched out where the galaxies are would be put in, so you wouldn't get the light of stars, just galaxies. And every time you went to a different part of the sky to do these sorts of surveys, you would have to change plates. Eventually, they were robotic, sort of like the things that pour your drink and then move the drink along at McDonald's and other fast food places do for the plates to shift them in and out. That still took a while. But the cool thing is with this experiment, the reason it's so valuable is not just because it is able to view things in higher detail. There's the telescope on the side there, but that it's able to reposition to look at other fields of view so much more quickly, because rather than moving the plates, those 5,000 robot positioners just reposition to known places in the sky where we want to be looking at galaxies, and off they go. So for that reason, there are tens of thousands of galaxies that are able to be plotted out each night, and millions of galaxies where only hundreds of thousands were before. Because of the success of this experiment, it's my understanding that the Department of Energy is likely going to be using this telescope until at least 2037, which is staggering to me in that it was facing the wrecking ball not too long ago. Just to show you how it works, I'll just take a closer look up here, the telescope itself. So the black area here is that experiment, that dark energy spectroscopic experiment. These silver hoses are for coolant, and the black hoses, so there's one there, there's one over here. That's where those fiber optic strands go from the experiment down into cryostats a floor below this telescope. So essentially, there's a closer look at it there. This is the eyes of the DESI experiment, and down below, about a floor or two down below here, are the brains of the experiment. So there's a quick look at, and there's the control room. Part of it is a lot of vacuum tubes and dials, and other parts are more of a touch screen SpaceX sort of endeavor. But $67 million US, about $1/10 billion, and it's doing just fine. It's kind of like an old antiquated battleship that's been pressed out into service. This is sort of the cast iron version of the sort of telescope that is usually being built, and there aren't a lot of prime focus telescopes that were built lately. So for a bunch of reasons, this was a perfect, this was a match made in heaven to have this experiment be mounted on this telescope. Okay, we've got about, I think, 6 or 7 minutes left. I want to take you to the final large research telescope on the mountain. It's a little bit different. And it is the only one we actually can't see from here. But I've taken an extensive video to show you. Basically, I'll just turn you around here. We're going to be going down this road, and behind this telescope to the left and to the far side of the campus. I should mention that Kitt Peak has officially 22 observatories. Depending on what you call an observatory, it's, you could say there's as many as 26 observatories and many more individual telescopes that range in size from this little 6 here to our largest telescope, a 24-inch telescope at the visitor center, to the 4-meter Mayall telescope mapping out the universe behind me. So we had the Mayall telescope mapping out the universe, the WIYN telescope discovering exoplanets. I don't have time for it, but I'll just show you over here are 2 of the Spacewatch telescopes. They are, as you can imagine, looking for near-Earth objects and hoping to give us humans a 30-year window to know if something is going to come really close to the Earth or even hit the Earth. They can't do anything about that. They don't laser blast them apart or anything. That was the original idea from the Space Guard Institute, which in fiction Arthur C. Clarke came up with, which from the book Rendezvous with Rama. But that's what actually inspired the Spacewatch system, of which these 2 telescopes are a part of. We won't have time to go into those, but I want to take you over to the largest of the Kitt Peak Visitor Center telescopes, as opposed to the research ones which we've been looking at. This telescope is the largest, until recently it was the largest solar telescope ever created, and it was divested in 2017 and handed over to the visitor center to use for public use. I'm going to do a screen share, and we'll switch over to a few views of that I took earlier today to show you, and I'll tell you a little bit about that, and then I think we'll have time for questions. Okay, there we go. So this is the McMath-Pierce Solar Telescope. It was built in 1960. It was built in the 1960s. It's 110 feet tall. It is the size and dimensions, including the length of the Statue of Liberty, if you included the pedestal that the Statue of Liberty is on. Aside from the 100-inch Mount Wilson telescope, this is the will soon be, once we reopen it to have the optics actually looking at the sun and at night the moon and planets. It will be, after Mount Wilson, the biggest telescope in the world in history for public outreach, for fun. For use for just looking through it, for the pure joy of looking through an insanely big telescope. We're going to go inside the telescope here. I'm going to open the door up and we'll be able to see into the tunnel where the light from the heliostats that you saw at the top of that toppled over number 7 shape, which is a giant sundial, direct down through this tunnel and into a control room. So look up to the right. All right, there are those heliostats. There they are. So there's a 2-meter one, and then two 1 meter heliostats left and right there. We'll zoom out here and see the path of photons from the sun travels down this tunnel, 500 feet. Sorry, I'm used to using feet now. You can do the math in meters. We can't quite see all the way down, but 500 feet down, then all the way back up from some of the mirrors that light bounces down to these mirrors right here, and then into a control room a little further down below. There's sort of a gated off square below these optical elements, and that's where the light of the sun goes. This is an F54 telescope, and so the filtering happens simply by the amount that light travels, the distance light travels before it goes onto essentially a table in the control room, which I'll show you right now. So I've driven, it's big enough we have to drive to the other part of it. I've driven down to the lowest floor. The telescope itself goes further into the ground. We spent $4.5 million starting to build a science center in here. This will house exhibits. The reason it's so long is that this is the structure of the telescope. We didn't have any choice in what shape the science center would be. This was going to, in 2017, it was divested. It was no longer able to do useful research. Researchers at this telescope discovered water on the sun, water vapor, and explored solar oscillations and various other things to do with the spectra of light from the sun. There are the control mechanisms. This is the main control room table that light from the sun would go onto through spectrographs, although it's just going to be going onto a flat table. From this square area here, this opens up, light from the sun goes from the heliostat, the main heliostat, down from mirrors down onto that table there. And this not only shows the light and light spectra of the sun, but the moon, bright objects at night as well. The best view of the moon maybe in the world is available from this telescope. So we're excited to get the optics back to show it. We can't see the sun right now until we get the heliostats working, but we can travel to the sun by going to, oh, we turned it off here. I'll go to another part of our tour where it's back on, by going to our one and only so far functioning demo, exhibition, I should say, at the Science Center called the WIYN on the University Center within McMath-Pierce Solar Telescope. So I jokingly call a reverse planetarium. We do have plans to build a planetarium here as well. This is the Science on a Sphere. Excuse me, a bug just went into my, swallowed a bug. That's the beauty of live being outside amongst the telescopes here. Science on a Sphere, and I'm just controlling it here so you can see we're control the whole world, moving the Earth around. But we can go to the sun. We can go to things like the king of the planets, Jupiter, and see it and just orbit around it and show different elements of the environment, ocean currents and temperatures, the aurora, but also, like I said, we can go to the moon, for example, and we can orbit around the moon, go to the far side of the moon. The view of the moon from this telescope was so spectacular, is so spectacular, that the Apollo astronauts trained here, all of them, during the 1960s and 70s before they landed on the moon. And finally, this is a view of the DESI survey, and this is very cool. This is the first time this has ever been shown, mapped out in a three-dimensional way, three-dimensional view of the universe on a three-dimensional stage, basically. I'll put that back just for a second, just to talk about that for another couple of seconds, and I think hopefully there's time for Q&A. I just think this is so cool that a telescope on this mountain that the Science Center is on made this map of the universe, this map of the expansion history of the universe. Blue is close, red is are the farthest galaxies, and this is sort of the sweet spot where we're flying in towards the part of the Milky Way that we were able to get through this. And this was all done in-house. The telescope discovered this, and now we're displaying it on an outreach endeavor in-house. And I'm just really excited with that. So that's some of the new things that are happening at Kitt Peak. And I hope I've left some time, maybe a few seconds or a minute, for some questions. I see a lightning flash, but we don't have any shelter-in-place warning, so I am technically still okay right now.
Good.
Yeah. Any questions about anything that we've gone to look at and go through?
Sure, absolutely, Peter. Well, first of all, thank you so much for taking the time to present to us. On-site live presentations are great, especially this kind of topic. So thank you so much. We definitely have time for presentations, and I'll turn it over to Ennio to ask them.
Okay. Hi. So our first question is from Ronan of Stag. Is dark energy like dark oxygen?
Oh, that's a good question. I don't believe so. There's basically the missing stuff in the universe is basically dark matter and dark energy, and together those are about 95% of the universe. Only about 5% of the universe is what we can see and measure, but I'm not too sure about dark oxygen. That's a good question.
So our next question is from Zapfan. How large a field of view does the galaxy watching telescope have with its prime focus?
Okay, I'm going to go back to the visual for that. It is, off the top of my head, I believe it's 4 or 5 degrees. I'm measuring that in full moons, but I'll go back to the graphic here. There we go. I'll screen share this. Okay, can you see this?
My video is
Awesome.
frozen, so
All
I
right,
can't see it.
Okay, so basically, that is about the amount of sky compared to the full moon that dark energy spectroscopic experiment, which looks like that, looks at a time. So it's quite a large amount of sky.
Our next question is from John
I would guess off the top of my head it's probably about 4 degrees. Oh, sorry.
Oh, no worries. Our next question is from John Wonderwick. How do ground-based telescopes and space-based telescopes complement each other, and are there research projects that use both?
Ooh, good question. I'm going to turn around to show you rather than tell you. I'm going to roll the dice and unplug from the power here. I've got to duck under the steel girders, so pardon me for a sec. Okay. There we go. So there's the WIYN telescope there, right over there. And so I'm excited to talk about that while we're talking about this. I'll show you this telescope that's actually involved in that. Now, first of all, and I'm not the world expert to talk about this, but ground-based astronomy, I think, since the age of adaptive optics, that to a large extent counteract the distortion of the Earth's atmosphere. You can have telescopes that are many, 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 many times the light gathering ability and the power of something like Hubble or even James Webb down on the Earth. There's still, in a lot of ways, no substitute for telescopes that are out in space, though. The telescope over here, the WIYN telescope, which is mapping out or basically identifying the masses and densities of existing exoplanets is working with the TESS Space Telescope survey that has already found those exoplanets, and basically taking those planets that have been discovered by that space telescope and where their masses and densities aren't known, and measuring their masses and densities. So we not only know that they're there, but we know more about them.
And our last question is from Eric Briggs. And his question is the Atom Block Telescope at Kitt Peak that is used for public outreach? Has Dietmar used this telescope?
Oh, I'm not too sure what that is. Sorry, the what telescope?
The Atom Block Telescope.
That is, as far as I know, not a telescope that is at Kitt Peak, but we do have, I will tell you, we have 6 public observatories. We've got this one right here, which is our roll-off roof observatory. It's just starting to rain right now, so this is perfect timing. I think we'll be able to wrap this up before it gets rainy. And then we've got behind us, right over here, is one of our domed observatories. We also have just behind this dome right here, called the Burrell Schmidt Dome, is our 20-inch public outreach. Oh, there we go, our 20-inch public outreach telescope. And down just through the hedges here, where you'll see over here, you can just barely see part of our solar telescope right through that hedge there. There's also an additional telescope plus an additional solar telescope. So we've got a total of observatories with 11 total telescopes, including a number of large hydrogen alpha telescopes, calcium solar telescope, and a large number of photographic and visible light telescopes that range from, I guess 16 isn't our smallest size, range from about 2 inches to 24 inches. But sorry, yeah, I'm not too sure what that other telescope is. It might be another observatory, but if I'm wrong, I'll ask around. But I've not heard about it in 6 months. Having said that, I got shown an observatory that I didn't even know existed a few weeks ago here, because there's so many telescopes here. So that's not to say it isn't here. I just haven't encountered it yet, perhaps.
Awesome, thank you. And that's all our questions.
All right.
All right. Well, my pleasure. Glad to be speaking with you guys here.
Thank you very much, Peter.